Hey everybody, today we're doing 5.5, completing the square. So when we complete the square, this is just the process from taking something from standard form to vertex form. Okay, so we're going to talk about how to do that. Why do we want to do that maybe? So one thing is that if you want to solve, sometimes it's easier to have it in vertex form. Also, when we graph coming up, that's going to be very helpful. Okay, so let's go in and talk about completing the square. So let's describe what a square is. So kind of the two things that we want to make sure when we talk about squares is that it has four sides. So like here, this would be a square, right? It has four sides. Okay, and all of the sides have to be the same. Okay, an actual square also has to have 90-degree angles, but that's not so important when we do these types of problems, okay? So the sides have to be the same. All right, so let's go look at this example. We're going to talk about here completing the square. So far we've got x squared. X squared is going to be our first box, right? Usually we plug that in when we do other types of stuff, like factoring or yeah, that's about it, okay? So if we have x squared, what do the sides have to be for this first square? Well, it has to be x and x, right? That's the only way that could multiply to give you x squared. And what do you know? The sides are the same, right? So that would be actually a square, a perfect square, okay? Next off we have is the 20x. So usually when we are doing like distributing or things like that, we combine those two boxes together. But we want those two boxes to be the same so that we would still have a square. So this has to be 20 divided by 2 would give us 10x and 10x. That means that the sides here would have to be 10 and 10 for this to turn out, okay? So now we have a box that have the same sides, x plus 10 and x plus 10. All right, so that's a perfect square. And then what completes the square? So the last thing is we're trying to figure out what this has to be, but we could just do that by multiplying. 10 times 10 would give us 100. Okay, so if you would please pause and try B and C. So again, we're always going to have this x squared will give us an x and x. If we had something out in front, it makes it a lot harder to complete the square. So oftentimes we would use a different thing if it's not. Okay, so we'll have x and x. Next we have half of negative 18 would be negative 9x and negative 9x. So the outside parts would have to be negative 9 and negative 9. And then what completes the square? Well, it's just negative 9 times negative 9, which is 81. Okay, and then this last example, we would have x squared, x and x. Half of 6 is 3, so 3x and 3x. And then what completes the square? Again, that would be 3 times 3 is 9. Okay, so when we complete the square, we end up having two factors out in front that are the same. Okay, if that's the case, then we could rewrite this as x plus 10 times x plus 10. But maybe to make it a little more simplified, we could write it as x plus 10 squared. Okay, so now we're getting to something that looks more like this, where we end up having this squared term. Okay, and that's our kind of our goal here. So for this one, if we were to rewrite this, this could be x minus 9 squared, and this would be x plus 3 squared. Okay, so when you complete the square, you end up getting a perfect square trinomial, so that's what this is up at the top, which means that you can rewrite it as a binomial squared. Maybe I should point it over to here. Okay, that's a binomial squared. Okay, So now let's go to like an actual problem that you would see. Okay, so here we have a quadratic. We want to complete the square. So again, we're going to start the same way. Half of 6 is 3, and that's our middle term. What completes the square? Again, we multiply 3 times 3 is 9. But here you might notice that it's not 9, it needs to be 10. So here we're going to add this extra box for what we need to get to make it be 10. So 9 plus 1 would give us 10, okay? Does that kind of make sense? So we can't change the numbers. They have to still be the same. We're just reorganizing this equation. So then our final equation would be something like x plus 3 squared, because we have two factors that are the same, and they're being multiplied, so we can use an exponent, and then plus 1. So that would be our equation in vertex form. I guess this is an expression, so we'll talk about the difference between that in a minute. Okay? All right, next off, I'd like you to pause and try these if you can. So we've got x squared and x. Half of 10 is negative 5. So negative 5 and negative 5. And when you multiply those, we end up getting 25. But we don't have 25, we have 20. So what do we need to do to 25 to give us 20? We would have to subtract 5. So then our final answer here would be x minus 5 squared minus 5. All right, last example. X squared, x and x. Half of 4 is 2. So we have the same sides. Complete the square gives us a 4, but we don't have 4, we have 7, so we need to add 3. So our final answer would be x plus 2 squared plus 3, and we're good to go. All right, so there's a couple things on the next page, and make sure you pay attention. So this is an equation, which usually we have it equal to 0 when we're solving. Here, for C and D, this is an equation, it's equal to y, and this would be called a function. And we could plug in an x and it would give us a y, and we could plot that information if we wanted to, or, okay, it's kind of like a vending machine. If you were to plug in an x, you get a y. If you put in $1, you get a Pop-Tart, or something like that, okay? Although it's probably more than $1 now. Okay, so let's do a couple of these real quick. So really the only thing that's different is when you're done, you're going to need to make sure it's equal to 0 at the end, or y equals, like the other example. Okay, so we'll draw our little box and our extra box. Okay, and then we will do our x's. Half of 16 is 8. What completes the square would be 64, but we don't have 64, we have 71. So we would have to add 7. Okay, so our answer, our final answer would be x plus 8 squared plus 7 is equal to 0. Okay, and so like here we could solve, we could subtract 7, square root both sides, don't forget the plus or minus, and then subtract the 8, and that would give us our two solutions. Okay, here's another one. Do our little box and put in our x. Half of 18 is negative 9. Complete the square would give us 81. But we don't have 81, we have 20. So we have to subtract quite a bit. We have to subtract 60. So our final answer would be x minus 9 squared minus 60 is equal to 0. All right, so watch out for these. It's not because of the y equals, it's because of something else. So let's look at do our little box, put our x, half of 6 is 3, and then complete the square is 9. Okay, so again, it's not 9, it's -4. So this is where people sometimes have a hard time because we're starting at something positive and we need to end up something negative. So basically starting at, like if we did a number line, if this was 9 and we want to get to -4, we have to go back 9 and back 4. So that would give us a -13. Okay? An easy way to kind of remember this is that we're always basically taking this, subtract this, and that would equal that. Okay, so if you want to think of it like that, that's great. If you just want to think about, we have to start at 9 and we have to go down to 0 and then down to -4 or something similar. But as long as these two end up giving us -4, then you're good. So either way works best for you. Okay? Oh, I guess you probably should finish this one up. So we'll have y equals x plus 3 squared minus 13. And then our last example, draw our little box, x squared, half of -10 would be -5, and -5 times -5 is 25, but we don't want 25, we want -11. So I think we would have to subtract 36. Again, think about the best way you'd like to do that. If you just want to take this, subtract that. If you want to go from 25 down to 0 and then down even further to -11. Okay. All right, and then we'll write down our final answer would be y equals x minus 5 squared minus 36. Okay, so just a little note here. Again, if you were asking to solve in standard form and it's not factorable, and maybe you don't want to use the quadratic formula, you could always try and complete the square, and then you could use PEMDAS backwards to get x by itself. One other thing I should probably make a little note over here is that completing the square works well when, number one, a is 1. So here a is 1. Okay, so if you look at all those examples, a is 1. That makes it really nice because it makes it be a square thing, right? If you had 3x squared or 2x squared, you can't multiply equally to give it a square. So a has to be 1, or it works well if a is 1. And then second off, it works well if b is even, because we want to be able to cut that middle term into 2 equal parts. So if you had something like -7x, if you want to divide that by 2, then you end up getting 3.5, -3.5. And that doesn't, I mean, it works, but it's much harder to work with fractions. So usually people try and stay with these two conditions because that's when it works really well. Okay? Also, one other thing is if you took something like this, ax squared plus bx plus c equals 0, and if you complete the square, then you end up getting the quadratic formula. And if you're ever interested into that, you could kind of probably search that on YouTube and find something that kind of shows you how that happens. But basically, you're doing the same thing, you're just using A, B's, and C's. Okay? Anyways, have a great day. Let me know if there's anything I can do to help you, and we'll see you later.